Yes, I think we should start. I request Dr. Sangeeta to kindly start the session.
Yes, sir. Hope I am audible, sir.
Yes, yes, fine.
Good evening, everyone. So, I welcome you all for the second session of AICTE ATAL FDP on sustainable practices in energy and environment sector. So, it gives me an immense pleasure to introduce on this online FDP session Dr. Makarand Pimplapure, sir, the founder and managing director, MaxSpeed Technologies. Sir has completed his MTech from IITM and pursued his PhD from the University of Twente, Netherlands. Sir has over 22 years of experience in research and leadership in process engineering, process intensification, reaction engineering, and flow chemistry. Sir has held positions with prestigious multinational corporations including Corning, DOW Chemicals, GE Plastics, and Indorama. Sir, with over 12 years of dedicated experience in flow chemistry, he has specializing in developing flow chemistry capabilities, conducting the techno-commercial evaluations, and also optimizing processes by transitioning from batch to continuous operations. He is also providing the continuous flow scale-up solutions. Sir is having a proven track record of collaborating with the clients across various industries, including pharmaceuticals, petrochemicals, polymers, and also the agrochemicals. Sir is an expert in generating valuable experimental data in flow chemistry, and is also providing the data-driven insights for the informed decision making, which includes proof of concept development, the techno-commercial viabilities, assessments, etc. As a trainer and an influencer, Sir assists industrial clients in developing the flow chemistry capabilities and also setting up the laboratories. He also provides training to academic institutions along with the hands-on training to industrial professionals on fundamental and advanced flow chemistry concepts. So with this brief introduction, I ask Makarand Pimplapure sir to take over this session.
Thank you. Thank you so much for the introduction. So first of all, would like to thank Dr. Ghodke, DY Patil International University for giving me this opportunity to interact. It's always pleasure to interact with large group and share some of the insights and some of the learning I had over my professional life. So I'll share my slide.
Yes, sir.
You can just let me know if it is.
Yes, sir. Please share.
Is it visible?
Yes, sir.
Okay. I'll just take it on.
Full screen.
Yeah.
Yes, sir. Perfect.
Yeah. Is it moving?
Yes, sir. Perfect.
Okay. 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 Great. Great. So today I'm going to talk about sustainable manufacturing practices. To introduce this topic, basically this is a very complex and multifaceted topic because it involves various methodologies, various strategies, many different technologies, sometimes which are overlapping, interconnected, and sometimes they could be very different from each other. Second most important thing, this is a evolving field. So there is a continuous growth. This field is continuously growing due to increased regulatory pressure because of the technology advancements and societal demands for the sustainability. This is driven by need for balance for profitability and environmental responsibility. So this is true for any small organization. So any small scale or big organization, they will have to have balance between the profitability and then environmental responsibility. But even if we look at the country level, so a country like India, which is a developing country, in order to increase GDP, we need to increase our per capita energy consumption. But how we can do it without increasing, how to do it under sustainable condition, that is one of the question, which is always very complex, and probably there may not be a single answer for such questions. So scope of this presentation is the focus will be to covering breadth of the topic rather than dwelling deep into each individual methodology. This is just to give sense what is meant by sustainable manufacturing. So initially I will start with some of the concepts. Personally, I always believe that a definition of any concept should be very clear. So throughout my presentation, whenever I'm coming up with new concept, I try to define, will try to give some context, how that concept was evolved and what is the background for that context. And at places there would be comparison with the equivalent concept, how they are, what is the overlap, how they are similar to each other, and what are the differences. So if we look in the literature, so earliest modern publication on sustainability, if we ask this question, so the earliest report is Bertland report in 1987. So it is by United Nations World Commission on Environment, WCED, Environment and Development. So it was the first major publication to formalize sustainability in global discourse. So it introduced the widely recognized definition of sustainability, which shows the interconnectedness between environment, economy, and the society. So, what was the motivation and immediate reason for UN particular branch taking up this initiative? So, first and foremost, it's an environmental concern. So, in 1980s, the world was facing mounting evidences of environmental degradation. So, including deforestation. So, even I think if you remember within India, deforestation is one of the widely top topics since mid 80s and 90s. Pollution, of course, with growth, with increasing number of vehicles on road, the pollution has been a big problem, particularly for developed world since 1980s. Resource depletion. So again, I think it is one of the major international political issues, availability of petroleum, and then the various prediction to what extent this petroleum is available, and then how it is going to impact economic development and human well-being. Then next is like it's a growing realization that economic growth was often achieved at the expenses of environment. So as I was just saying, like in order to improve growth, you need energy, and then energy, it always you need energy and you need different material, and then if you increase that throughput and production, your traditional knowledge will tell that you end up having more pollution and more sustainability issues. Next important target was global inequality. So it is widely known that between industrialists like developed countries and developing countries, there was the gap is huge, and then that gap is widening over the period of time. So the question was how to balance this economic progress, environmental conservation, and social equity. Then economic and energy crisis. So there was energy crisis in 1970s where there were a lot of political issues in terms of petroleum production. And then this was coupled with growing global economic instability. So this was one of the primary reason for rethinking of resource use and economic models. So what were the key concepts in Brundtland report? So they introduced sustainable development, and then its a formal definition is a development that means the needs of the present without compromising ability of the future generation to meet their own needs. This is very comprehensive. It is practical as well as philosophical in nature, and then it can act as a mission and vision for any organization and the government organization who would like to work in the sustainability. So most important aspect is it emphasizes the interconnectedness between economy, environment, and society. So all three factors are important in order to achieve sustainable development. And then, key advocates for these reports were reducing poverty and inequality, managing natural resources sustainably, and then international cooperation to address environmental challenges. What were the outcomes and what kind of discussion triggered by this report? So, first was global recognition of sustainability. So, a report emphasized that sustainability should be central policy in the decision making, and then uh, it spurred government, NGOs, and businesses to integrate sustainability into their agenda. Formation of international framework. So then this report laid groundwork for Agenda 2021, which was adopted in Earth Summit in Rio de Janeiro in 1992. So this summit becomes the next major milestone. It focused on global environmental and developmental goals. And third most important outcome was policy and awareness. So it encouraged nations to adopt long-term environmental strategies and cooperate on global environmental issues like climate change, deforestation, and biodiversity loss. So with this background, like what is a fundamental definition of sustainability in our context? So sustainability again refers to ability to meet need of the present without compromising the ability of future generation to meet their own needs. Again, three key pillars: environmental sustainability. So this is about conserving natural resources and ecosystems. Social sustainability. This is like promoting equity, inclusion, and community well-being. And economic sustainability, supporting long-term economic growth without harming the environment or society. So let us look at one of the example which is kind of well studied and well understood, and we will use that example to understand how the actions related to sustainability can be done. What could be the different models? What are the different players which will be involved in finding out the solution for the problem? So a well-known ozone layer problem is basically ozone layer depletion was caused by widespread use of ozone depleting substances like chlorofluorocarbons in the refrigerant, aerosol sprays, and solvents. So this resulted in increased UV radiation reaching the Earth's surface, leading to health issues like skin cancer and environmental damage. So who were the key stakeholders who were affected by this problem? One is, of course, society, human beings, health risk, agriculture productivity decrease that was observed. Then ecosystem, it also impacted various ecosystem like marine life and wildlife. And then, of course, industries, because industries who are responsible for generating product related to refrigeration, aerosol, solvents, they will get impacted based on society's response to understanding of these issues. So multifaceted approach was adopted to resolve this crisis. So first is a technological innovation. So this is a development of CFC alternatives, HCFCs and HCFCs, and natural refrigerant. So it involves a lot of data generation and R&D for development of alternatives. Second most approach is regulatory framework. So it is a compliance mechanism for governments and industries. So some regulatory frameworks need to be there, which will guide government and industry. So it will have two aspects. One is the timeline, by what time they need to make such changes. And then some guidelines with respect to the kind of solutions available. Social awareness is most important, because then with all this data available, public adoption of eco-friendly product become one of the essential aspects. And most importantly, corporate responsibility. So adoption of certain alternative sustainable alternatives. So again, this can be done in a two-way. Like positive way is kind of encouragement or rewarding for doing such thing, and second is discouragement. That means some penalties are to be made when compliance is not there. So what are the results and lessons from sustainability? So most important is there is an observed ozone layer recovery. So this recovery started in 2000s, and it is expected that full recovery would be done by 2060. So again, this was not possible without the participation of everyone. So what are the key sustainable takeaway from this? So one is scientific evidence is the driver. So The scientific data is important for development of policy. It will also give a direction for innovation or some of the problem definition where innovators can look into. Most importantly is global collaboration. So government, industries, and public, they need to collaborate on such things. Adaptability in technology, so innovation by industry and academia. That is again a part of scientific data generation. And most importantly, regulatory pressure. So again, enforcing deadlines and enforcing standard, it becomes one of the tool to achieve such goals.
Sir, may I interrupt?
Yeah, sure.
Sir, looking into this ozone layer depletion, the more of depletion has taken place near Alaska and all, where there is no human being residing, much of the human being residing. Why so?
Yeah, so probably it's to be very frank, it would be very difficult for me to give very precise. But then I think the answer can lie in the global warming and climate change. So basically, we need to have very fundamental understanding of global warming and climate change, because these are the, some of the local activities happens, and then because of how overall climate change in terms of what is the flow of your wind, what is the flow of your water and everything, that will be done that. So that is a very broad answer. Very practical problem is example. I can say that the Delhi pollution problem is not because what happens in Delhi, but what happens in Punjab. So that is a very loose connection, and probably that could be the reason. I hope I try my best to answer your question.
Still in a doubt, sir.
Yeah, sure. Yeah, so sometimes, as I was saying, like there are some concepts which are overlapping and which are correlated with each other. So one is climate change. So climate change refers to long-term changes in weather patterns and temperature. So these are influenced by both natural processes. For example, volcanic eruption can lead to a generation of lot of greenhouse gases, and it can impact the climate change. And then it can be also because of the human activities like deforestation, industrial emission, so on and so forth. Global warming, again, by definition, global warming is the observed and ongoing rise in Earth's average surface temperature due to natural or human activities. So again, there are specific data about the global warming in terms of average temperature of different locations on the Earth. And sustainability definition is like it's a framework for meeting present needs without compromising future generation ability to meet their own. So it includes all economic, environmental, and social dimension. So if you try to compare this concept, so global warming is basically concerned about the human activities, particularly green gas emission. Climate change, it's more about it's the impact of global warming which changes the climate. And if you look at the sustainability, basically it is sustainability talks about the unsustainable resources use which contributes to emission and degradation. So impact of in terms of impact, global warming, it talks about temperature rise. Climate change talks about disruption in ecosystem, weather and livelihood. And then sustainability, it aims to prevent or mitigate both by reducing environmental harm. So focus for global warming is always temperature is the key matrix, and that is being done. Climate change talks about broader environmental consequences. And then sustainability, again, it talks about environment, economy, and social well-being. So what are the mitigation kind of strategies for global warming? It is typically a source of urgency of the solution. So idea is like how fast we can reduce the overall emission. And then there are many various treaties in terms of what should be the target in terms of temperature rise, and 1.5 degrees I always keep on hearing, and some time frame. So they talk about pre-industrial level, what is the temperature, average temperature, and how fast we can bring to that level. So that, again, the target goals keep on changing. Sometimes it is 30s, 50s, 60s. So climate change, again, the role mitigation is like framework for action and adaptation. And then for sustainability, it guides practices like renewable energy and reduced waste and equity. So what is a practical example of their overlap? So basically, if we talk about global warming, so it is the root cause is carbon emission from vehicles contributing to temperature rise. Impact in terms of climate change. So this is this warming leads to heat waves affecting agriculture and water supplies. And then in recent times, we have seen a lot of flooding in various parts of the world. Sustainability solution. So by promoting electrical vehicle and renewable energy to reduce emission, so this will mitigate global warming, and then it will be lessening climate change effect. So the solution offered will be sustainable, and it will take care of global warming and climate change. Second most important aspect is circular economy. It is being talked for chemical industry as well as for other industries. So what are the shared goals for sustainability and circular economy? So both aim to reduce environmental degradation, conserve resources, and enhance long-term economic viability. So the circular economy, it provides practical framework for achieving sustainability goals by focusing on reducing resources extraction and waste. In terms of resource efficiency, so sustainability emphasizes conserving resources for future generation, whereas circular economy, it achieves this by designing products and system for longevity, repairability, and recyclability. So in simple term, for example, if you need 1 ton of material for any purpose, then circular economy will ask this question like, instead of consuming this 1 ton, if you can consume it in 1.5 years or 2 years, or whatever byproduct you get by use of this 1 ton of material, whether they can be recycled or they can be reused, something like that. In terms of sustainability, the question would be, are there any alternate material for this 1 ton material which will be more sustainable? That is, the amount of energy required, amount of material required to generate that is minimized. So what are the climate actions? So both frameworks support reduction in greenhouse gases, GHG emissions. And then sustainability advocates for renewable energy, whereas circular economy emphasizes reducing emissions through material efficiency and lower waste generation. So one of the, again, simplified question kind of view would be, sustainability will tell us that you stop the coal power generation and move to other renewable resources, whereas circular economy will tell that, like, even if it's a coal power, can you use the carbon CO2 generated from that, the fly ash which is generated from coal, if it get consumed, probably these are the solutions which represent circular economy. Yeah, so in terms of scope, sustainability is broad. It's because it incorporates the aspects of environment, society, and economics. Circular economy is more focused on material and resource recycles. Approach sustainability is holistic. It involves governance, equity, and energy. Circular economy focus approach is more operational, so it focuses on waste reduction and resource reuse. Implementation level, again, it's sustainability is at policy level, and it's talks about societal transformation, whereas circular economy, it's like industrial, and it talks it impacts the product life cycle. So what are the key performance indicator for sustainable manufacturing? So we have talked about 3 aspects: environmental, social, and economic. So for environmental, you can understand emission of greenhouse gas or greenhouse gas emission rate, carbon footprint, percentage of waste generated per 1,000 of product unit, percentage of reusable or recycled material, energy use per 1,000 product, total consumption of water, renewable energy use rate, sustainable water. In terms of society, KPI would be employer satisfaction rate, number of training hours per employee, health and safety rate, diversity rate, equality rate, total expenses for social initiatives. In terms of economic, of course, it's very straightforward. Percentage of income for recycling program, investment in technology rate, percentage of production site with environmental certificates. So if you look at manufacturing methodology, so you always start with traditional manufacturing, then there is an improvement. There are many various different methodology like lean manufacturing. So what it does is, compared to traditional manufacturing, your shareholders' value would increase with implementation of lean manufacturing. The next step is green manufacturing. And then finally, most importantly, sustainable manufacturing. So again, this is an ideal picture. So intuitively, you believe that in order to have any manufacturing in a sustainable manner, probably your initial capital cost would be high. You need to do a lot of research, a lot of compliance need to be done. But in ideal condition, overall end result would be, in terms of shareholders' value, sustainable manufacturing should result in a higher shareholders' value. So if you talk about sustainable manufacturing, you need to talk about 3 levels. So first level is a product. So you're talking about specific product. Then a question to be asked is about the longevity of product, environment viability of product. Are there any alternatives? So what is the most suitable product for that particular application? Then second step would be in terms of process. So what are the processes implemented in terms of generating that product? So how those processes can be efficient in terms of energy, in terms of waste generation, in terms of water usage. And then third layer on that is the system. So how this overall system would work in an efficient manner, in a most sustainable manner. So one of the aspect for sustainability is 6R approach, which we have seen in the earlier plot also. So what is the definition of 6R approach? So first is reduce. So it talks about minimize waste generation by reducing resource consumption. So in chemical engineering perspective, it is like increasing selectivity. So then you can get more amount of product per kg of the starting material. You reuse, extend the life of the products and components. Recycle, convert the waste into usable material. Recover, extract value like energy from waste material. Redesign, improve the product design for minimal environmental impact. And then remanufacture, that is refurbish and restore the used product like new condition. So always there are 3 phases of manufacturing. So first is a research, then further development and commercialization. So during research, basically you develop, evaluate and examine a specific sustainable requirement such as energy, resource use, pollution, climate change impacts. So this phase of the model has high potential as it helps to ensure sustainability at pre-competitive level, and it focuses on manufacturing environmental issues. Development, so it improves development phase. It improves the environmental performance such as environment footprint assessment, life cycle analysis, and design for environment by using appropriate methods and tools. And at commercialization level, basically it refine the previous phases and cooperate with supplier, vendor, and customer so that overall ecosystem becomes sustainable. So what are the enablers for sustainable manufacturing? So if somebody wants to get into sustainable manufacturing, what are the enabler he or she need to look into? So first is a concept. So concept, it presents comprehensive analysis of economic, social, and environmental cluster as well as other relevant consideration. So you need some basic concept, like you need to define what is the sustainability and what are the goals for each of these factors. Then there are methods and tools. So development, improvement, and enhancement of smart tools and methods to support concept of sustainability. Data generation, this is to support environmental impact, sustainability assessment. More detailed, comprehensive, and robust data are needed across overall product life cycles. Manufacturing practices, this is to build sustainable indicator for measuring and monitoring processes to increase sustainability awareness among suppliers and customers. Government policy, this is to achieve incorporation between companies and government through sustainable program and environmental factor like clean process policies. Research, academia and industry research that is needed to enhance the sustainability system by focusing on manufacturing, design and environmental aspects. And then overall integration. So all previous aspects, they need to be integrated, which represent environmental, economic and societal sustainable solutions. So this is a simplified picture considering some of the aspects. So sustainable manufacturing concept. So what you need is policies and procedures, community engagement, environmental control, sustainable design, and support for sustainability. So this is one of the simplified, simple model for assessment approach. So if product is being generated, and if someone want to assess like if the overall process is sustainable or not sustainable, this is a simple matrix. So any product development, it incorporates manufacturing cost, energy consumption, waste management, environmental impact, and person and health EHS basically. So at design phase, basically you have various analytical and numerical model to predict manufacturing cost, energy consumption, waste management. And then based on designers' experiment, based on the guidelines which are available, there could be prediction in terms of environmental impact and EHS impact. So then all this data is combined to have an integrated model. By understanding system, by implementing system contents, you try to optimize this method, optimize this solution. And then once you get the optimum solution, the question to be asked is whether it can be acceptable or it needs improvement. So no improvements are needed, then that is an acceptable solution. If improvements are needed, then again, you need to repeat this aspect couple of times. So how to use this kind of model is simple in terms of chemical industry. It is, for example, if you want to produce some product, and then if you have 2 or 3 different routes for same product, then best way to do is you try to generate this model for each of the route, and by comparing the impact of each route, you can finalize. So such models are typically available from chemistry perspective, in terms of if your chemistry performance is good. Sometimes like chemistry and energy managements are available, and then it stops there. But this is kind of a one level higher model where you not only incorporates the energy and material cost, but also waste management, environmental and EHS at the design level itself. So in this assessment matrix, just to get sense what are the manufacturing costs, all the direct costs, indirect costs, capital cost. Energy consumption, typically it is for production, transportation, facilities, etc. Waste management, it is in terms of recovery, reuse, recycle of consumable, all the packaging material being used and scrap parts being used. Environment impact is greenhouse gas emissions as a function of your total throughput, disposable waste, noise pollution and water pollution. EHS matrices would be in terms of injury rate, absentee rate, working environment condition, exposure to unsafe condition. So as I was saying, like this environmental aspect and personal and health aspect, it depends on designers' experience, judgment, and then over the period of time, there would be some standard for each industry, and this data will keep on improving over the period of time. And then that data will make this such kind of model much more robust. Another aspect at designing level itself, like defining objective becomes very, very important. So if certain objective is part of your optimization strategy, then it will ensure that that is achieved. So there are different aspects of sustainability. So for example, there is a design for manufacturability, design for functionality, design for economy, design for environmental impact, design for 6R, or design for social impact. So based on the industry, based on the situation, a combination of this design optimization target can be defined for each specific product or project, and then that can be one of the input for the model what we talk about. Now, second aspect of sustainability is Industry 4. So let's talk and understand a little bit about Industry 4. What is the industrial revolution? So time period is typically 2010s onward. We talk about Industry 4 has arrived. So key feature of Industry 4 is integration of smart technology, IoT, Internet of Things, artificial intelligence, AI, data analytics, and real-time decision making. So what are the major innovation? It's IoT, AI, big data. So it is not the data for one small process or one small product or localized data, but it's a real-time data coming from all the assembly, sub-assembly, supplier, everything. So big data and analytics and cloud computing. So cyber physical system. Another aspect is additive manufacturing, like 3D printing is one of the major innovation. Impact, so it will result in smart factories and interconnected system, enhanced efficiency, customization, predictive maintenance, real-time monitoring, and autonomous operation. So brief comparison between Industry 1, 2, 3, and 4. So it is well known Industry 1 is like a steam engine phase. All work has been mechanized. Industry 2 is incorporation of electricity. So it is kind of a semi-automated. Basic electrification was done. So assembly lines were developed as a part of Industry 2. Large-scale production started. Industry 3 is about computer and IT. So some sort of automation started. Implementation of robotics and PLC started. Limited IT, and then things were programmable, and then these are automated process. So Industry 4 is a one level above Industry 3, where we are talking about smart technology, smart automation, IoT, AI, big data. This is highly connected industry, and then it works on the real-time analytics and smart factories. So how the Industry 4 would look at a single organization level? So you always have sensors to measure all. So when you talk about real-time data, so if you talk about any chemical process, then you need all the kind of sensors to collect that data in real time. Then there are actuators like automated response based on the sensors. This is a one level of decision making. Then second level is like all data collation, and then it will go to a system management system. Then the data from management will go to planning, which will ensure that at the small scale or at the part of plant it is optimized, and then overall manufacturing. So the complete end-to-end manufacturing can be automated, and real-time decision can be done, and then over and above that is the final control. And if you talk about end-to-end integration, so this kind of system get implemented in each of these organizations. So if you look at a different organization, it could be a production organization, design organization, logistic organization. So operation of each corporation is automated, and then each corporation is talking with each other in terms of data in a real time. And then some of the decision of one corporation will impact the decision of second corporation, so and so forth. So the whole I think small world is interconnected, and decision and then overall optimization of system will be possible. So what is a smart factory in nutshell? So smart factory basically compared to traditional factory will have limited or fixed resources. Smart factory, it will have diverse resources. Fixed routing, typically in terms of supply chain, smart factory, it is a dynamic routing. Shop floor control network, this is a comprehensive connectivity. Traditional control is at separated level. Each aspect is independently controlled or optimized. This is a deep convergence, so that the global optimum is achieved. This is an independent control. This is a self-organized. Traditional factory, it's a isolated information, and smart factory, it's a big data. So now let's look at another example. It's like a story of solar power. So if you look at development of solar cells, in 1839, photovoltaic effect was first discovered by French physicist Edmond Becquerel. And this was kind of a foundation for solar technology. So in 1954, first practical silicon solar cell was developed by researchers in Bell Lab. And this solar cell could convert sunlight into electricity with efficiency about 6%. So this was the birth for modern photovoltaics. So initial, if you look at the implementation of solar, so in 1970s, so initial commercial use was in off-grid system like satellite, remote telecom. And then companies like Exxon, they invested in solar for oil rigs. In 1980s, lead to government subsidies like developed countries like USA, Japan, Germany. And then it lead to a large-scale production. And then early solar farms were emerged, but still the costs were very high. So probably it was part of subsidies and part of a government push, which were result in such thing. In 2000, there was a drastic cost reduction due to technology advancement, mass production, particularly in China, and policies in Germany like feed-in tariff. So I think this is also implemented in India now. So you can have your own solar system, and then extra power generated can be sold off in the grid. Investment tax credit, I think that is also something is possible in India these days. And then utility scale solar farms become widespread. So 2010 onwards, like solar achieved a grid parity. So that means the power generated using solar was at par with all the other power generation systems. So there are massive installation in California and like Badla Solar Park in India, which is one of the biggest capacity of the solar park. So what are the, again, some of the things what we can learn from success of solar is what are the key aspects. So one is improved efficiency, technical development. So technical development, it reads in, it resulted in cost reduction. There were some specific solution were needed, for example, energy storage, batteries, smart grids. Regulatory development. So government incentives, renewable portfolio standards, and carbon pricing. Economic of scale and market dynamics. So mass production, increased competition, global supply chain, it all lead to a economic of scale, and it becomes affordable. Declining cost of fossil fuel alternative. So I mean, because of all these factors, the power generated, the capital cost and operating cost, it becomes competitive, and then it result in adoption of this technology. And then public and corporate support. So awareness by public, and then some corporate involved. So big companies, they decided that part of what percentage of their power will be renewable. So such kind of pledges also is important in one is it will directly impact, and indirectly it acts as an advertisement. Now, coming to what is the chemical industry and what is the sustainability aspects in chemical industry. Basically, improving process efficiency and energy efficiency, it has been a primary focus since industry inception. So in that sense, part of sustainability exposure was already there for chemical industry. Then innovation, they were initially driven by economic consideration only, but it resulted in significant sustainability benefits. So particularly, I mean, petrochemical industry is extensively energy consuming organization. So any improvement in energy consumption, of course, it gives a lot of economic benefit, but then indirectly, if you reduce the amount of energy per kg of product, then definitely such solution becomes sustainable. Some of the key development which were in the initial phase, like in mid and end of 20th century, is heat efficient equipment and methodology, process optimization technology, advancement in catalysis, development of alternative material. So all these aspects where sustainability was in sense was not the primary motive, but if you look at the bigger picture, one of the side result for additional result for adaptation of this methodology or development of this product is the overall solution being more sustainable. So all this advancement, it highlights the industry's indirect contribution to sustainability. So let us look at some of this advancement and which are kind of indirectly responsible for sustainability. So plate heat exchanger, it is a well-studied example. Energy efficient, high heat transfer, it reduces energy consumption. It is responsible for effective recovery and reuse of waste heat in processes. Material optimization, so these are very compact, large surface area can be generated in a very small area. And then the efficient operation reduces fuel and resources consumption. Of course, the environment benefit is lower greenhouse gas emission and reduction in cooling water and utility demand, conserving natural resources. Other interesting aspect is pinch technology or heat integration in distillation column. So as this picture shows, basically it shows separation of three components, 4 components typically. Then you have series of three distillation column. So any distillation column, it will have reboiler and it will have condenser. So pinch technology helps you to define if one of the reboiler can be acts as a condenser for another. So in this case, the reboiler for first column acts as a condenser for next subsequent column. So different permutation combination are possible. So in this case, both of these reboiler acts as a condenser for third. So reboiler for first 2 column acts as a condenser for third column. In this case, it is in series. So reboiler for first is condenser for second, and then reboiler for second is condenser for third, so forth. So such kind of configuration, permutation combination can be done, and then there is a very detailed analytical method. Models are available, and then by using such models, you can have optimized distillation column. So it will optimize not only the performance in terms of material recovery, but it will also ensure the energy saving. And basically, if there are cost model available for your material recovery and energy saving, so overall optimization can be done. So such kind of methodologies are responsible for energy saving, for process efficiency, cost reduction. These are very, very essential, and they were kind of a phase changing for the industry like petrochemicals. Advanced reactor technology like fluidized bed. So traditionally, for many application, packed bed was the reactor of choice, and packed bed has its own limitation. So if you compare packed bed, fluidized bed with packed bed, so it provides excellent heat and mass transfer, and then it can be used for operation like catalytic cracking and polymerization and many such operations. So overall efficiencies of this operation, they were improved, and in some cases the specific operation became possible because of the availability of this technology, fluidized bed reactor. Next technology, reactor technology, is autothermal reactor. So it is in situ heat generation, so it becomes extremely energy efficient. So the idea here is you don't provide energy from externally. A part of the raw material is getting consumed in generation of heat. So for example, a partial oxidation or exothermic gas phase reaction, these are some of the example of autothermal reactors. Catalyst technology. So catalyst, of course, it improves the reaction rate and selectivity, energy efficiency. So it work at less drastic condition. It will ensure that energy required. So instead of very high temperature, catalyst will ensure that same chemistry can be done at much lower at a much lower temperature. The average reaction rate for catalytic process would be higher than a conventional, and then it will also result in a better selectivity. Versatility. So again, there are different kind of catalyst, and same kind of catalyst can be used for multiple application. So it is versatile in that sense, and yeah, data generated for one type of project can be implemented. I mean, that will help us to optimize second project in much faster pace. What are the environmental benefit? It's like a reduction in waste, less energy, reduction in the raw material usage. Membrane technology, again, it is high in efficiency, efficiency in terms of both material and energy. It is compact, it is scalable. It leads to a continuous process. So continuous process are always better better to control, and they provide the better solution. Flexibility. So there are many applications possible using membrane technology, and it's one of the growing field. Environmental friendly, because it lead to minimization in chemical use, low maintenance, and these are very compact. So these are kind of initial technologies which were developed independently. So they were solution for some specific problem, and they become very popular and they become generalized too. But if you look at from a broader sustainability perspective, there are various concepts which are available in chemical industry, like green chemistry, process intensification, continuous process technology, or flow chemistry. Sustainable chemistry. So let's look at some of these aspects. So let us look at 12 principles of green chemistry, and part of it is already, I think, they become part of some of the other philosophies, and some of the things look very familiar. But in terms of a principle, green chemistry comes up with their own 12 principles. So first is prevention. So avoid waste generation rather than treating or cleaning it later. So that is one of the objective whenever new chemical process is being developed. Atom economy, design a process to maximize the incorporation of all material into final product. So again, selectivity improvement, catalysis is one of the way to go. Less hazardous synthesis. So the objective is to use method that minimize toxicity to human and environment. So it will encourage to use less hazardous starting material or less hazardous solvents. Solvents which are difficult to remove from product, all those things will get prevented if you try to follow this guideline. Safer chemicals, so design product to effective while reducing toxicity. So try to understand toxic behavior of each starting material and try to choose the route which chooses the chemicals which are less toxic. Safer solvent and auxiliaries, so minimize use of auxiliary substances like solvents or choose safer alternatives. So energy efficiency, so conduct reaction at ambient temperature and pressure to reduce energy consumption. Renewable feedstock, so you use raw material that are renewable rather than depletable. Reduce derivatives, like minimize unnecessary derivation steps that require additional reagent and product waste. So the question is, there are two methodology. One is a chemistry route where you avoid some intermediate. So you find a route where less number of steps are involved. Otherwise, one of the solution could be a continuous technology where all these things can be done in situ, and then a couple of reactors can be combined to have a continuous process. Catalysis, use of catalytic reagent that they are more efficient than stoichiometric reagents. Degradable design, so create products that break down into non-toxic substance after use. Real-time analysis, develop methods for monitoring reactions to prevent hazardous conditions. And then inherent safe chemistry, so design processes and chemicals to minimize the risk of accident like explosion and leaks. This was green chemistry. Now let's look at process intensification. Again, let's look at what are the fundamental definition given by different authors over the period of time. So process intensification is again, in principle, it is a paradigm shift. So if you look at the chemical industry, a primary goal is always enhancement in the efficiency. So whenever you talk about a marginal improvement, you talk about improvement in the energy efficiency. But if you are talking about the change by which your equipment size reduced by order of magnitude, then those solution comes under process intensification. So definition of process intensification, it talks about reduction in both main plant item and the installation cost. So it is minimization in the equipment size, and then all the cost associated with the installation. Size of chemical plant. So strategy in reducing the size of chemical plant needed to achieve given production. So this definition emphasizes that it does not talk about reduction in the consumption or reduction in the amount of material to be produced, but only thing is the size of the equipment which is needed to generate that production should be minimized. Next definition, it talks about decreasing equipment volume and energy consumption. Cheaper, safer, sustainable technology. Sustainability is part and parcel of a process intensification paradigm. Yeah, again, it is a paradigm shift. It is not the marginal change compared to conventional equipment. It is a paradigm. And then next definition, it talks about profitability and uncertainty. So it is again important, as I was talking earlier. Intuitively, one would believe that if you go for sustainable solution, then capital costs are high, your R&D costs are high, and then overall solution could be less economical. So that could be true in a short term. But in long term, what we always talk about, what are the stockholders' return value, and then it improves when the solution are sustainable. This I call it as a visual definition. So what is the meaning of process intensification? So this is a traditional petrochemical plant, very long columns and identifiable from very long distance. Probably in somewhere there could be some exhaust gases can be seen emitting from it. So this whole plant, if it can be converted or if it can be kind of compressed into office kind of space, then that will be the solution process intensification, because then the amount of material being produced would be exactly same, but then you are doing it in a office kind of space instead of a very big manufacturing plant. So what are the elements of process intensification? So process intensification, in a way, as defined earlier, it's a philosophy. So any methodology, any technology, or any equipment which reduces the equipment size by order of magnitude for given same production, then all those solutions will come under process intensification. So the process intensification could be in terms of equipment, type of equipment being used, and then it could be in terms of methods. Again, when you talk about equipment, then it could be equipment for carrying out chemical reaction, or it could be equipment for unit operation. So some of the examples are spinning disk reactor, static mixer reactor, static mixing catapacks, monolith reactor, micro reactor, heat exchanger reactors, supersonic gas liquid reactors, so on and so forth. In terms of equipment for carrying out mass transfer operations, static mixer, compact heat exchanger, micro channel heat exchanger, rotor stator mixer, rotating pack bed, centrifugal adsorber. In terms of methodology, there could be methodology or methods, there could be philosophy, which will ensure that it results in the overall reduction of the equipment. So multifunctional reactors. So the most important and classical example is reactive distillation. So here reaction and distillation are done together. Similarly, reactive extraction, reactive crystallization. Membrane reactor is also part of multifunctional reactor because you can carry out reaction as well as separation simultaneously. Then hybrid separation technologies like membrane absorption, membrane distillation, absorptive distillation. Alternate energy source, most common is UV radiation. So that can be done. Centrifugal field, ultrasound, solar energy, microwave. These are some of the alternative sources of energy. Some other methodologies like supercritical fluid. So we know that heat transfer and mass transfer, they're excellent high under supercritical condition, and then that can lead to a improvement in overall efficiency of the process. And then dynamic reactor operation, again it is a kind of model intensive. Instead of operating your equipment under steady state, there could be a periodic variation which can give the better result or better efficiency of the performance. Some of the example of process intensification is, again, as we have seen, plate type of heat exchanger. Advantages are energy saving, floor space saving, ease of capacity adjustment, and ease of maintenance. Spinning disk reactor. So principle of spinning disk reactor is basically intense shearing is achieved. Shearing and mixing is achieved in a very thin film. So the overall mechanism is there is one dynamic plate and one plate which is rotating at extremely high velocity, and this will lead in generation of very thin layer on the surface, which is of the range of 100 microns. And with this kind of layer, if you are talking about liquid chemistry, then this will result in a very intense mixing, and it can lead to a very high rate of reaction. So typically residence time in such reactor is of the order 0.2 seconds. And then there are some chemistries where intrinsic kinetics is very, very high, and those chemistries can be conducted in equipment like this. So this is kind of, these are suitable for reaction with high intrinsic rates, like nitration, sulfonation, even some polymerization has been tested using this equipment. One of the inherent limitation is because this is a mechanically moving part, lab scale and pilot scale are easily possible. There are limited example of production scale implementation of this technology. Photochemistry, as I was saying, so this is example of alternate source of energy. So there are traditional batch reactor where in a glass environment you put the electricity source, and then a reaction is carried out. It could be a liquid or gas liquid. Traditionally, typically mercury lamps can be used, which gives a wide range of wavelength. But nowadays, LED lamps are available with a very specific wavelength. It will improve the overall energy efficiency, and then in a continuous manner, a very small reactor is required to achieve the desired conversion. Now moving to micro reactor technology. In case of reactor technology, the performance of any equipment depends upon the mass transfer and heat transfer characteristics of the equipment. So conventionally, this is one of the snap from the literature. What it tries to do, it compares the mass transfer and heat transfer performance. So for example, plate type of heat exchanger can provide very high heat transfer, but mass transfer is limited, not that high. Some improvement in plate heat exchanger can improve the mass transfer, and this equipment can be improved. So there are various equipment like stirred tank, injector, loop reactor, static mixer, plate heat exchanger, rotating pack bed where mass transfer is very, very high, but then heat transfer is limited. So in this matrix, microstructure reactor are the reactor where the heat transfer is on the higher side as well as mass transfer is on the higher side. So theoretically, from the performance perspective, you can expect that the performance of this equipment would be much better than a conventional equipment. So this is a typical setup of the flow chemistry. So as explained by our coordinator, so I'm personally working in the area of flow chemistry, and this is a solution provided by MaxSpeed Technology, my company, in the area of flow chemistry. So now I'll just take you through a very small example of the process which we implemented using our equipment for a customer. First of all, let's look at the advantages of flow chemistry again. When we talk about sustainability, but if you look at the fundamental technological aspect, the flow chemistry advantages gives because of the two aspects. One is a process intensification. Another is because you are operating it in a continuous manner. So aspect of process intensification is improvement in the efficiency, that is improvement in the raw material usage, reduction in the equipment size, footprint reduction, I'm going to explain one example where what we were able to achieve is we are able to convert 3000 liter, 3 kiloliter, 3000 liter reactor into just 1 liter reactor. And then since it leads to reduction in solvent and waste, so it is a part of greener process technology or sustainable if you talk about the energy efficiency of this equipment. Then there is an improvement in safety because of the size reduction. So this becomes inherently safe, which is again one of the paradigm for greener process technology. What are the advantages because you are operating it in a continuous manner? So one is the quality control or automation. So these reactors are operated in a continuous manner, and in order to operate it under steady state manner, all parameters need to be monitored and that need to be controlled. So all the philosophy of QBD, quality by design, would get implemented using this equipment. This will result in reduction in manpower. Again, improvement in safety because of the automation and because of the interlocking. Since all parameters are continuously being monitored, it is possible to automate the system, and some system level decision can be taken just to ensure to avoid any unsafe condition. So this is an example where we converted batch process into continuous one. Conventional batch process was like this. So typically 2 to 3 kiloliter reactor was being used. Initially, starting material and solvent was fed. Then this is cooled to a -5 to -10 degrees Celsius. And then this was followed by a gradual addition of chlorine. This is to ensure temperature remains in limit. So one of the limitation of batch reactor is heat transfer capability, heat removal capability. And in this case, it is controlled by addition rate of the chlorine. Once complete addition is done, then you have to wait for a couple of hours, and then the reaction is done. And then this will be followed up by separation steps. So this was conducted in a system like that. So one of the feed was liquid. Instead of second pump, there was a supply of chlorine. This reactor, which is jacketed, it is connected with heating cooling circulator to operate a reactor at very specific temperature. And so DOE kind of approach was implemented, design of experiment, and then the process was optimized. So what was the comparison between flow and batch? Basically, conventional process was semi-batch. This was the continuous. The temperature for this chemistry was -20 to -10 degree. In this case, the chlorination could be done in 30 degree Celsius ambient condition. So you can use utility from the cooling towers. A solvent, a large excess of solvent. So in conventional process, they were using 80% of solvent. In flow chemistry, only 40% solvent was required. Conversion in this case was in the range of 90%, and then in continuous process, it was 99%. Byproduct, it was like 10 to 12%. In continuous, it is 9 to 11%. Very marginal decrease, but it was acceptable limits. Residence time, overall time required for a single reactor is 16 hours. In continuous process, it was less than 2 minutes, around 2 minutes, and subsequently it was decreased further. So what is a result of reduction in residence time instead of 16 hours, since we are now doing this chemistry in just 1 minute? This is the comparison. So this is a size comparison of a batch versus a max speed flow reactor for same amount of production. So in this case, per day throughput was in the range of 800 kg. This is the 3 kiloliter reactor. It is being operated for 16 hours, and then they are using 80% solvent, and then the final throughput is 800 kg. Now, compared to that, current continuous flow reactor size is very small. So it is on average, it's 1.5 liter because we have compared it for 16 hours. If you operate it for 25 hours, then you need 30% reduction in volume. So instead of 3 kiloliter, the production reactor volume is just 1.5 liter. Residence time is 1 minute. That is, you are getting your product every 1 minute. And then the solvent use is 40% instead of that. So in 16 hours, 1.5 liter reactor will be able to produce same. If throughput requirement is higher, then either you can increase the size of reactor or you can put parallel lines. and increase the reactor by order of magnitude, throughput by in multiples. Yeah, so these are some of the cases and some of the backgrounds, like where this sustainability, what are the different methodologies, what are the different associated concept with sustainability, and what are the specific solution which are offered by chemical technology as a conventional solution, because of the motivation was different. But then currently all this combination of this solution can be used to generate overall sustainable manufacturing for the chemical industry. Of course, I have not talked about some of the other examples or some of the aligned topics. So one of the aspects of sustainability is biorefinery. So instead of a petroleum refinery, the biorefinery is getting momentum. So you can generate chemicals from biorefinery, and that is one of the competitive technology for sustainability. Second aspect of sustainability is different materials. So polymer has changed the life of human being. Because of the polymer, like a lot of things which were not possible earlier, they are becoming possible. So your packaging weight has reduced, so your transportation cost has reduced. Some of the things which were not possible, like liquid transportation, was almost next to impossible. It become possible because of the packaging technology. So each of these technology, they have their own kind of impact, and development of this technology is because of the chemical industry, or some of these are part and parcel of the chemical technology. So these are kind of a broad background. Now let us look at some of the problems and criticism on sustainability. One of the biggest problem could be greenwashing and data manipulation. So sometimes it can be used because of could be because of the international political situation. So big developed countries, if they want to push their agenda, the data shared by them, maintained by them, or developed by them, there could be chance that it could be the scenario of selected data which is being used to dictate their terms. Political and ideological barrier, as I was saying. So one, I think, most important example which could impact overall sustainability movement is, I think, the current the upcoming US president. So he don't believe in global warming, and he thinks that climate change is not real. So with such kind of situation, funding by such big developed countries can impact, and it can impact overall efforts for sustainability. Unequal global commitment, because then again, if you talk about reduction or commitment by government, then what is a baseline? Because are you talking about total pollution or total greenhouse emission done by individual country, or you talk about per capita, or you talk about the emission or pollution done till date from the industrial revolution? So all those things can become a little bit challenging, and then it can derail the discussion and cooperation on sustainability. Corporate influence and power. So in a golden age, like in the age of Industry 4, all people are connected, all data is available, but then again, you don't know whether those data are correct or they are manipulated. So information is available, and then that can change the behavior of people. Sometimes, like a big corporation, they can decide their own terms and conditions. So for example, Tesla, they have money power. Google, they have money power. Facebook, they have money power. So they can decide certain things, and they can try to force. So of course, there are government which will try to intervene, but sometimes that can be a challenging situation. Access and equity issues, again, because this is between developed countries and developing countries, who develop the technology, at what cost it is available, when it is available. All these things can impact the implementation of sustainability. Lack of enforcement and accountability, as I was saying, sometimes can be challenging. I think all sustainability goals, they are voluntary, and people are, I mean, each government are trying to do that. At organization level, based on the government policies, some of the things can be enforced, and some of the things could be voluntary. Ultimately, economic pressures on small business. So if you talk about small business as well as small countries, so it is economic versus the sustainability. As I was saying, in long term, sustainability will provide you the best return, but in short term, it will be responsible for capital cost, R&D expenditure, so may not be possible for each and every organization. Some of the challenging question, which may not have very clean answers, but I mean, I would like to put these thoughts in front of everyone. These are some of the points to ponder, because we don't have all the data, we don't have knowledge. So I would always say that this is a transient phase, something which seems to be very good turn out to be not so good, and something which was very bad, it turns out to be good. So not a right comparison, but like if you watch movies in 50s and 60s, so smoking was so common in a closed container, everywhere smoking was allowed, and over the period it was now identified like all the disadvantage of smoking, and then it is frowned upon initially, then were rules and regulation, and now it is prohibited, and now it becomes punishable. So if you look at the society, it is always in transient. It is because of the availability of data, it is because of the awareness, and it is again most importantly availability of specific data. So one question is like growth versus sustainability for developing nations. So can India grow without compromising sustainability in short term? So question is like, if we in order to increase our GDP, we need to increase our energy electricity capability, and then the short way for us is coal fire power plant. So in short term, till we get independent, so at least I already show one example of solar power plant, but what are the cost, what is the possibility of large scale implementation of such? So that trade-off would be there. I mean, this is India, but again could be true for again less developed countries compared to India. They will have to face this question, and they have to make their choices. Success of polymer, as again I was saying that because of that, a lot of advantage is there. But now a lot of studies, they are talking about the impact of sea ecology due to microplastics. So there are some studies which indicate that this microplastic is getting integrated, it getting assimilated in the marine life, probably, and then it will have its own impact. So again, these studies are quite preliminary. We don't know what is the end result for that. So in short term or in intermediate term, use of polymer seems kind of a blessing, but it long term, it can have its own ecological impact. So at least, I mean, in India, we have seen some other problems in terms of rainwater drainage and all. So at least those kind of problems are easy to tackle if government make appropriate policies. So in that sense, that is also some aspects of sustainability, because if a small rain can kind of impact your city life, then again, that is not a sustainable solution. But that is one part, but other part is largely the impact of polymer on ecology. Again, I talk about electrical vehicles. So it seems to be a very lucrative option at the moment. But then what are the economics, what is the ecology, and what is the politics of lithium? So we don't know the complete life cycle studies. There are already some dissents, people claiming that long-term EV may not be as advantageous as it turned out to be. Second would be politics of lithium. So there are limited resources of lithium, whether it will lead to control by some of the powerful countries. That seems to be that needs to be seen. So these are challenging questions. There are no easy or immediate answer for them. We need to keep it in mind. Each solution could be in short to medium term, it can be beneficial, but then end of life we need to check, and probably these are the things which should be part of data generation for sustainability study, and then probably I would say some of the solution what our generation is going to develop, or next generation is going to kind of evaluate us based on those solutions. So with this, I think this is more or less I wanted to share. Thanks for your attention. I would be glad to hear any comment somebody has, if somebody has any experience to share. If somebody has any question, I will try my best, but I won't promise that I'll be able to answer all questions. Thanks for your attention.
Thank you, sir. Thank you so much. Now I request the participants, if you have any question, you can please take quick questions. Any questions from audience side? You can even
Hello, sir.
type in a chat. Yes, yes.
Hello.
Please.
Am I audible, sir?
Yes,
Yes.
sir.
Sir, actually, you have told regarding circular economy.
Yeah.
Can you say that it effectively works in India, particularly for plastic packaging?
Yeah. Yeah, so I think I mean some of the very easier or simpler example of circular example is like we talk about extension of the product use. So I think India is known for that. So I mean now there are some regulatory kind of pressure where you have to re-register your vehicle after 15 years. But traditionally Indians are known for use their like one generation, two generation they use
Correct.
their vehicles. So that is I mean one way of looking at. Second most important is our paper recycle. So I think it's not very it's not I would say it is unorganized sector, but it is very efficient. So I think our paper recycle would be at par. Plastic recycling is a challenge because of the spread and all. But I mean some of the I think social behavior for India, they are I would say they are in line with the circular economy.
Okay, sir. Thank you.
Sir, one doubt, sir, regarding the lithium-ion batteries.
Yeah.
Lithium is not the concern, I guess. It's cobalt, which is a heavy metal that is present in the battery, and there are alternative batteries what are being identified like sodium-ion batteries, vanadium redox flow batteries, which have better shelf life and
Correct.
a number of cycles also.
Okay.
So more than 20 years of cycle for vanadium redox flow batteries. Why they are not being implemented, sir?
I'm sorry. So I have very limited knowledge about. So we need to connect with people. But typically, I mean, conceptually, I would say that any new technology, if it is not commercially being used, one is sometimes there is always a difference between a proof of concept which is being done in a lab scale versus the practical implementation. So many times in lab environment, the data generator is really under ideal condition, and it can give you a lot of efficiency. But when you try to implement in a real life, there are a couple of problems. One problem could be design problem because you don't know how to design it under real life condition. Second could be you are able to design it, but the performance of equipment in the real life would not be as efficient.
Fine, sir. Thank you.
Great. Good question, sir. Yes. Any other questions from the participant side? Okay. Moreover, I would like to quote here. Sir has presented his last slide as a part of challenging questions only. So I think sir has covered the questions also. So even if he has covered, if anyone is really looking forward to the question, he or she may ask. Otherwise, I think he has elaborately explained everything related to the manufacturing aspects of the industries. So now I request our session coordinator, Dr. Sangeeta, to propose the vote of thanks.
Yes, sir. Thank you, sir. Firstly, I would like to thank today's speaker, that is Dr. Makarand Pimplapure, sir, for sparing his valuable time and sharing his knowledge in today's session on the topic sustainable manufacturing practices. Thank you, sir. Thank you for giving such valuable insights under this topic, which included some important informations like multifaceted approach to solve environmental crisis, comparison between industry 1 to 4, solar success key points, pinch technology, catalyst technology, principles of green chemistry, photochemistry, flow chemistry, and many more. Thank you very much, sir. I also thank all the participants for actively participating in today's session. Thank you.
Thank you, sir. Thank you so much. It was really nice hearing to you. Now, I request all the participants to kindly fill the feedback form, and the links will be shared to you very shortly. Hope you enjoyed today's sessions. Both speakers have fantabulously explained their topics. I'm thankful to Makarand sir again. And dear participants, we will meet tomorrow same time at 6 p.m. Thank you. Thank you so much. Utkar sir,
Thank
you
you.
can
Thank you.
please.
Thank you,
Utkar
sir.
sir, you
Yeah.
can please stop the link.
Thank you.